Hello and welcome to our third video in our Basic Linux series. In this video, we're going to cover a number of basic Linux commands that should make you relatively productive in the command terminal. As you can see, I've already opened up my command terminal. I've already started my virtual machine and I've logged into Kali. So from here, you can see that I've already got the terminal opened. And the first thing, typically in the shell, you'll see that you have information that's already available to you. You can see that this is typically the user that you've logged in as, and this is the host name of the machine that you've logged in as. Depending upon which shell that you're using, and it may vary between different distributions of Linux, the command prompt will also give you an indicator of where you are with respect to the path. At the moment, you can see there's a tilde here, and tilde is representative of a user's home directory, and I'll show you more about that in a little while. It can be used as a bit of a shortcut. Now, so if for whatever reason you don't have a shell that is demonstrating your name as in your identity, then you can run a command called who am I, and that will tell you who you are, and you can see that it's come back as Kali. If at any time you're unsure about where you are within the directories, you can always run a specific command called pwd, which is present working directory. So if I run that command, you can see it's returned /home/Kali. Now I'll make a quick observation here. In Linux, the directories are separated by a / as opposed to Windows, which is a \. Now that's an important concept to master, because within Linux, you need to make sure that you're using a / and not a \. Backslash in Linux is used as an escape character before special characters are used in a command. For whatever command that you're looking to use, if you're unsure about it, typically there's always included documentation as part of the distribution. This is accessible from a command called man, which is short for manual pages. To access the documentation, you would type man and the command that you're specifically looking for more information on. Most commands will have additional switches and parameters that you can provide that alter or modify the functionality of the command. Let's say, for example, I wanted to learn more about the command ls, which I'll demonstrate next, which stands for list subdirectory. So I can type the command ls, man ls, and you'll see that it comes back with a whole list of documentation and various switches and options that you can append to the command to modify its behavior. This is really important because there are often times when you can't remember a specific switch or a specific modifier, and you can quickly jump into the man pages and look that up quickly. So you can scroll down, scroll up, or you just press Q to quit when you've read or worked out whatever it is the switch that you're looking for is. So the next command I'll cover is ls, which I stipulated before is list subdirectories. ls is the equivalent of dir in Windows, and it will show you the list of files and directories in your current working directory. So if I type ls, you can see that it's just given me a basic listing of the directories. Nothing special, it's just output basic text. Whilst it's good if I'm looking for a file of some name, it doesn't give me a lot of information. And this comes into where we can include modifiers into the command, which is what I was suggesting before. If I type ls, and Kali is always intuitively trying to complete a command line or make suggestions, if I can do ls space -l, that's a modifier which says list subdirectory in long format. So if I press ls -l, you'll see that suddenly I have a whole lot more information available to me about the specific files and directories in this working directory that I'm in. So given that it's displayed additional information, this is a good segue to probably discuss various columns of information that is currently displayed on the screen. There are 7 columns. The first column defines the file type and the file permissions, and we'll go over the file permissions a bit later on. But here you can see a D is in the far left hand side of the column. This indicates that it's a directory. If there's nothing in that column, then it's a regular file. The second column lists the number of hard links to that file. That's an advanced topic that won't be covered in this subject, but just be aware that that's what that means. The third column lists the owner of the file or directory. And in this instance, you can see that Carly owns these directories. The fourth column is the group. When logging in, you're assigned a user ID and a group ID as well. So you can have a group that is the same name as your user ID, which is quite common in Unix or Linux environments. So you can see here that the group that this directory belongs to is Carly as well. And similarly, there's just a standard file here where you can see the owner is Carly and the group that owns this file is also Carly. The next column is the size in bytes. So you can see how large a file is by looking at this column here. The sixth column is the date stamp. This lists the date and the time that the file was either created or last modified. And the last column, the seventh column, is the actual file name or directory name. As I said before, you can have various modifiers for specific commands. And as we saw, that quite often commands are aliased. So directories will show up as different colors as opposed to regular files. Here you can see that the directories are showing up as blue, whereas the regular files are a white color. With modifiers, you can do such things as look recursively through directories. If I type in ls minus capital R, then that will recursively search through directories. And this is sometimes useful when you're looking for a specific file. You can see that I've run ls minus R and I've gone through the various directories that just happen to be empty. If I went to the root directory, then you can see that this is a whole lot more. And it's going recursively through all the directories, listing all the contents within those directories, the subdirectories, and all those files within those subdirectories. And that'll go on for a fair while. So I can stop that by hitting Control-C. In Linux, you can have hidden files as well. A hidden file is any file that starts with a dot in front of the name. So a dot file is considered hidden and you won't see it when you run the standard ls command. To see hidden files, you have to do ls minus a, which is list all. The a modifier tells ls to list all files, including hidden files. And here you can see there are hidden files in this directory, and they're typically configuration files for various applications and the like. In order to navigate around the various directories within Linux, you use a command called cd. Now cd is short for change directory and is also similar to the same command in Windows. So we want to go to the root directory. We can go cd /. Remember, it's a / as opposed to a \. And this will take us to the root directory. This command has a number of convenient shortcuts that are available to use. For example, if I press cd with no parameters, then it will take me to my home directory. That's just a standard default across all Linux distributions. If I do an ls-a to list all files, including hidden directories, you'll notice that at the very top here, there is a dot and a dot dot. There's the dot and there's a dot dot. So these are shortcuts or conventions within the shell that allow you to use these. The dot means this current directory, and the dot dot means the parent directory or the parent above. So at the moment I am in /home/Carly by running the pwd command. If I want to go to a directory higher, I could do cd/home, and that will take me to a directory higher. Or I could do cd /... and that would take me to the parent directory one level higher. And I could continue doing that to traverse up the directory tree. So obviously the next directory above this is the root directory because it's /home, / being the root directory. If I type cd /... then it's now taken me to the root directory. And I can do cd enter with no parameters, that will take me back to my home directory. When navigating the directory tree, there is such a thing called absolute paths and relative paths. A relative path would be where I don't need to list a specific starting point. But if you see here when I do an ls, you can see there's a directory in my home directory called documents. Now the formal path for this would be /home/Kali/documents. If I put cd in front of it, that will take me to the documents directory within my home directory. That's called an absolute path reference. But if I go back to my home directory, and you can see that I've moved back one to my home directory, and documents is now a subfolder of where I currently reside, I can do what's called relative path referencing, which is cd documents. This means I don't need to type the full path because it's in a subdirectory, or it's in a directory or a child of the directory that I'm currently in. And that also works fine too. If I do pwd or print working directory, then you can see it's /home/Kali/documents. The file names within Linux, the file names and the commands within Linux is case sensitive. For example, I can't do /CD/ to the root directory because there is no command that has cd in capitals. So you need to be mindful of this when you type commands and or file names. So if I wanted to do a listing of a specific file, I can do an ls-l, which is a long listing of the file, and I can type some file.txt, which is a file that resides in my current directory. And it will return all the permissions and all the attributes that we looked at earlier. But if I wanted to do an ls-l of some file, spelt the same, it's just in uppercase, that file doesn't exist. So again, this is an important concept. As opposed to Windows, Linux is case sensitive. If you want to delete a file, then the command for that is rm. And as it suggests on the command line, you can type rm help, and it will give you a small synopsis of how the rm works and its attributed switches and modifiers. You can also type man rm to get to the manual pages, and it will give you more detailed information on how to use the rm. So, for example, if I wanted to remove that file called somefile.txt, I would simply type rm somefile.txt. And lo and behold, that file's gone. I recreated that file because I needed it for another example. If I wanted to rename that file, the rename command is mv for move. So I would type mv, file name that's currently there or existing, and I would call it whatever name I wanted to call it. So you can see now that that name has changed. And you can also use the move command to move files around the directory structure. For example, if I wanted to move it into my documents file, I issue the command mv, I issue the file name that I want moved, and I issue the location that I want to move the file to. In this case, I'll be using documents. So now taking a look, you can see that file has disappeared. And if I go into the documents directory, which I'm accessing via relative path locations, then you can see that that file is now in that directory. If I want to see the contents of a file, I can use a command called cat, which is short for concatenate. Again, we can go into the man page and you can see that cat, concatenate files and print on the standard output. Standard output is your screen. Again, you can see the various modifiers that are available to us within using cat. You can read that at your own leisure. If I wanted to see the contents of this file, I can use cat and the file name, and it will show me the contents of that file. If, for example, I'm navigating around the directory structure and I want to view a file, I should typically make sure that it's actually a text file for viewing or an ASCII file. The display cannot show binary files or compiled files, and you can easily find out by using a command called file. So if I type file and I put in the name of the file that I want to test to see what sort of file it is, then it should come back and tell me that it's ASCII text. So you can see it's come back with ASCII text. And that's fine to view and or edit. So if we go and find ourselves a binary file, and I'm just finding a random one here, you can see that this is a binary file. It's telling me that it's an executable, it's an ELF, which is executable and linkable format, dynamically linked, and it's been compiled. So these aren't available for viewing. You can, but it may do nasty things to your shell. And as an example, I'll show you. I may be destroying my shell here, but that's okay. Nothing destroy and reboot won't fix. And you can see it's just garbage. Depending on the size and the content of the binary file, it may do strange things to your shell. In this instance, I was lucky and I got away with it. But that's a good test to see what sort of file it is before you start viewing it and opening it. I'll navigate back to my home directory. I'll go into the documents file. Now we're going to talk about permissions. So if you look at the permissions here, there are 10 attributes. If you think of these in terms of bits, it may make it a little easier to understand. The first bit is defined for determining whether it's a directory, a special block file, or if it's empty, it's a standard file of some description. The next 9 bits define the permissions for that file, and it's broken into 3 blocks of 3. Each 3 bits is a combination of read, write, and execute in that order. So if you look at this last block, you can see that it's set for read only, read blank blank. If that was read and write, then it would be RW. If it was read, write, and execute, which is how you run a program in Linux, it would be RWX. So they're the 3 specific bits that get set. The 3 blocks of 3 bits are broken down to owner, group, and other. Now, other in Linux terms is anyone else not in your group. So the rest of the world. So for this file, we can define specific permissions. So at the moment, these are the 3 permissions. I'll try and highlight those. They're the 3 permissions for the owner. Carly is the owner, and at the moment you can see that the permissions are read and write. So I have read and write permissions to modify that file. I don't have execute permissions because it's not something that can be executed. It won't do anything. It's just a text file and therefore shouldn't be set to execute. The next 3 bits, as discussed, define the group permissions. So anyone belonging to the group Carly, because this is the group to which this file belongs, anyone belonging to the group Carly has read-only permissions because the other 2 bits are empty. or unset. So another person may come along, and if they have membership to the group Kali, they can read the file, but they won't be able to write or modify the file. And the last bit, or the last group of bits, is the other, which is the rest of the world. So the rest of the world can come along and read this file only, so they don't have write permissions or execute permissions. This is a really core fundamental that you need to get across, the basic permissions within Linux. The three groups of 3 bits, owner, group, and world, can be defined in terms of 3 octets. And I call them octets because in binary, a 1 and a 1 and a 1 equals 8. 8 bits equals an octet. And we can change the permissions on this file by modifying specific octets. Again, the octets, the groups are user, group, and other, or world. For example, if I wanted to change the world or the other permissions that the rest of the world has on this file, I can use a command called chmod or chmod, change mode. And I would type chmod, O for other, it's O for other, U for user, and G for group. So we'll run through a couple of these so I can give you an example. I want to change the permissions for the world or other. So I'll type O for other, plus, because I want to add the permissions, and I want to add read and write to those permissions. And I need to stipulate the file that I want to change those permissions on. If I run that command and relist that file, you can see now that that has changed for that last octet. Remember, we have user, group, and other. If I wanted to set the executable bit, I could simply go O for other plus execute and the name of the file. And you can see now that the execute bit has been set, which means it's now executable and I can run it. It won't do anything intelligible. In fact, it'll error out. So, but you can do that. Now let's clear those permissions. And you can see I've wiped them out. Let's say that I wanted to make this file editable by the group. So I would type chmod, G for group, plus write, because I want to make it writable by the group, and the name of the file. And you can see now that I've now made that writable or editable by anyone in the group Kali. And this applies to any file on your system that you can change the permissions on completely. So let's remove those permissions and I'll show you how it actually will affect from the perspective of the user if I strip out the permissions for the user as well. So chmod group minus read write. And you can see I've stripped out the permissions for the group and I've stripped out the permissions for other or the rest of the world. And now I'll strip out the permissions for the user and you'll see how this works. U for user minus read write some file. So you can see it has no permissions for access to it whatsoever. If you recall, we viewed the contents of this file by using the cat command. But now when I try to view this file, I get a permission denied because I no longer have permissions myself as the owner. I can revert that back. And you can see that I've got those permissions back. So if I try and cat that file, you can see that I now have access to that. So I hope that explains a relatively difficult subject to try and understand, but just practice it yourself a little bit and hopefully you should be able to grasp that concept. The next topic I want to cover is the creation of directories and deletion of directories. So I'll go to my home directory and you can see that there are 8 directories there. And I want to create a directory called my directory. The command I would use is mkdir for make directory, and I'll call it my directory. And you can see that I've created my directory. Linux doesn't like using spaces in a name. For example, if I typed mkdir my directory, that'll have a different effect. That will actually create a directory called my and a directory called directory, because it sees my space directory as a parameter list. Instead of being one directory with my space directory, it's created a directory. What it thinks as a list is my and directory. So it's created both of them. And you can see that there's my and there's directory. So you need to keep that in mind. Spaces aren't well liked within Linux. There are ways around it, but that's more of an advanced topic. Okay, so the next one I wanted to cover is the removal of directories. So we've just created some directories. Now let's remove them. And the command to remove these directories is rmdir, and then followed by the directory name. You can see this directory has been removed. Important note that the directory needs to be empty before it will actually work successfully. For example, if I go into my directory and I create a file, you can see a file exists. It's empty, but it does exist. I can go back to our previous directory and I'll do an rmdir of my directory where we just created that file. And it should complain because it says it's not empty, so it's not sure what you want to do, and as a safety precaution it's failed. It'll allow you to, it's done this way so you don't inadvertently wipe out a whole bunch of data by mistake. There are ways around this. You can actually do an rm -r for recursively, and it'll wipe out all directories, subfiles, subdirectories, everything. Use this command with care. It is very dangerous. If I run that, you can see that it's deleted it without question. In creating directories, you can also create multiple directories chained within a path. And by that I mean, if I wanted to create a directory called my directory, oops, space, let's not do that, /files/documents, it will complain. And that's because it's thinking we're doing relative path access. It's expecting my directory and file to exist, and it's trying to create the document directory. So it will try and create the last parameter in that list. It's assuming that this path already exists. It doesn't, so that's why it's complaining and has errored out. To get around that, we can modify our command by using the -p switch, and this will create a complete path without the other directories needing to be there. You can see that completed without error, and now we have a my directory, and within my directory we have a file directory, and within there we have our document directory. So that's a quick little shortcut that you can use. Now, on occasion, there may be need for you to actually run some administrative commands. For example, mounting an image file, which we will cover in a later video. But in order to run those privilege commands, you need to do what's called ascending to privileged user mode. To do that, we use a command called sudo or super user do. So that the idea behind that is to run a specific command as a super user. The idea is that you could run sudo and whatever command you want, and it will ask you for your own personal password, and it will run it with root permissions. Again, this is a dangerous thing to use. Typically what I would do is just go sudo su. Now the su command is super user command, and that will actually make you ascend to super user. If you run su by itself, it will ask you for the root password. Now in this distribution, the root password hasn't been set, so you can't log in directly as root. The concept is that you will ascend to root using these utilities. So you do that by running sudo in front of su, and that will authenticate you and allow you to ascend to super user status. So I've run sudo su, and now it's saying to me, well, this is the standard boilerplate warning that you're now going to become root, which means that it assumes that you know what you're doing and will often not prompt you for error checking or are you sure kind of dialog boxes. It will just do it silently, and many mistakes have been made in doing this when people haven't understood what they're doing. So this is the password for Kali it's asking me for. So I'll enter the password for Kali. And now you can see my prompt has changed to a red. I'm now root, and you need to be very careful whilst in this mode because you can do some serious damage. Ultimately, you can reinstall the virtual appliance if you destroy your machine, but you may also destroy some of your valuable lab work inadvertently. So we will actually use this command when we're looking to mount directories and image files, and that will be the topic of another video. Okay, so that brings me to the end of this video, and I hope that's given you a basic understanding of the various commands available to you. If you have any interest, please do your own research on terminal commands, because you can become very proficient and very powerful by using these commands. What I've shown you is just a minute fraction of what's available and the power that you can use or bring to bear using shell commands. Okay, thank you for your time, and I'll see you in the next video.